Hi guys, you're watching Airfoil noise prediction using machine learning regression models. So NASA has performed a series of aerodynamic and acoustic tests of 2 and 3-dimensional airfoil bead sections conducted in an anechoic wind tunnel. A dataset is obtained from it, and it comprises different size NACA 0012 airfoils at various wind tunnel speeds and angles of attack. So the span of the airfoil and the observer were the same in all the experiments. And the data set consists of the following columns, which include frequency in hertz, angle of attack in degrees, and chord length in meters, free stream velocity in meter per second, suction side displacement thickness in meters, and scaled sound pressure level in decibels. So here the scale sound pressure level is the target for us, which we have to predict. So our job is to create a regression model which best predicts the target value, that is scale sound pressure level, using the given attributes. So you can download the data set from here, like UCI or machine learning repository. So and you can upload it in your notebook. As you can see that I have already uploaded the data file in .csv format, airfoil underscore noise, and let's go to the coding part now. So coming to the coding part, first we have to input the data which we have collected in a data frame to a data frame, and for this we'll make use of Panda library, and if we run this command, so the data frame get created with and by this command we'll get the first 5 rows of the data frame. So when we run this, we'll get, this is how the first 5 rows of the data frame looks. So we also imported the numpy package, which we'll be using in the later part of the problem. So now the next step is to uh, we have to separate the data into attributes and targets. So our target is SSPL, so I'm taking storing that column in the variable y, and I'm dropping that column from the data dropping it, and I'm storing the data in X. So now this X contains the attributes, and Y contains the column, like target column. So I'm gonna run this. Before we train the data into various regression models, we need to split the data into training and testing data set. The testing data set is used to check for the overfitting of the training data set for evaluation of different data sets. So for evaluation of different regression models, we'll make use of mean squared error and R2 score and mean absolute error, which we have imported over here from sklearn.metrics. And to split the data set into training data set and testing data set, we'll make use of train test split function from sklearn.model underscore selection. So xtrain, xtest, ytrain, ytest, and when we call this function, we are giving x and y as the input, and we are mentioning the test size 0.2. So 20% of the data will be in testing dataset, and remaining 80% will be the training dataset. So the x will be splitted, and it will be stored 80% of the first 80% of the columns is stored in xtrain, and first 80% of the rows is stored in xtrain, and rest 20% is stored in xtest. And similarly for y's, first 20% of the rows are stored in ytrain, and the rest 20% is stored in ytest. So I'm gonna run this code. It's taking more time. Okay, it's the code is run. So one point we need to make note of here is the test size is 0.2. So in later part of the problem, we are gonna see how the how a model works for different data set decision like 60% and 40%, 70% and 30%. So right now we'll stick to this 20%. So now we are going to train the various regression models one by one using training data set and check for overfitting of training data set using the testing data set. We are using, as I said earlier, we are using root mean squared error and mean absolute error and R2 as evaluation parameters. The various regression models which will be trained and compared over here are linear regression, and it includes the experiments with the dataset division. We are going to see the regularization technique, ridge, lasso, elastic net, uh, like ridge, lasso and elastic net. So we'll be also be seeing the polynomial regression model. Then we are going to see experiment with the polynomial regression. Yeah, polynomial regression, and we'll experiment with the degrees also. Degrees of polynomial. We are experiment with 2 and 3 and 4 also, and then we'll go to decision tree regression and random forest regression. So let's begin with linear regression. So for linear regression, I've imported this linear regression from sklearn.linear model. So I'm gonna create a model of type linear regression. I'm gonna fit the model of train. I fit the model with the training dataset xtrain and ytrain. So I'm gonna run this code now. So once the model is trained, now we're gonna test for the testing dataset. So y predict is equals to model dot predict xtrain. So it gives the prediction for training data set, and we are going to evaluate it using RMSE R2 and mean absolute error, and then we are going to do same thing for testing data set and find and evaluate it. So when I evaluate, we'll get the following values. So mean absolute error is 3.7 and root mean square error is 4.8593, uh, and R2 score is 0.50937. And for testing data set it is 3.568 and mean absolute is 3.568 and root mean squared error is 4.55748 or something, and R2 score is 0.539244. So one thing is clear that there's no overfitting of the data set. If there is a overfitting of data set, so trained data set, so then we'll not get the similar values in for the testing data set also. We would have get much error, high error. So this makes us sure that the trained data set is not overfitted. So now we are gonna plot the uh, scatter plot for between y test and y prediction, actual value and predicted value for testing data set. So and we'll run this. So if the uh, data is if the prediction is accurate, so then all the points would appear on this line. So there's, so as you can see that there's a the scatter plot is spread across above and below the line also. So this means that there's some error, you can see over here. So now we'll go with ridge regularization model. So for that I've imported the ridge model from the same sklearn.linear underscore model package, and now I'm gonna fit the model and evaluate it. So we got so close values. So 5.244609. Okay, the problem is we have not run it yet. So first we'll run it and then we'll evaluate it. So we got much lesser than when compared to the normal linear regression model without any regularization. So we are getting 0.506, and I'm going to plot this scatter plot, and it comes like this. And now they're doing the same thing for lasso also. So here you can see much difference from what we have got in the previous two models. Like it's like R2 score is 0.53, and in another one it is 0.50, but in lasso regularization we're getting as low as 0.23. So when we plot in this data plot from this, so there's much error over here. As you can see, it is spread far from this line. So now for elastic net, let's see what happened for elastic net regularization. So again we are getting very less values as is the 0.23, and this is how the scatter plot looks now. Okay, yes, you can see there is much error in the prediction. So now that's all with the regularization techniques, and now we are gonna experiment with different dataset division. So we already experimented with 0.2, 20% and 80% and 20%. Now we are going to experiment with 70% and 30%. So when I run this whole program, so I'm getting 0.46, which is less than what we got in 0.2. So we got 0.53, and now we are getting 0.46. So we plot the graph. So this is how the scatter plot looks. And now we are gonna check for 60% and 40%. So it's giving better results for testing data set, and but poor for training data set. So it means 0.52 for training over here. Previous one we got 0.53, but it's improved for testing data set from 4.6. Now we got 0.49. So this is what the scatter plot looks like. Now we are done with the linear regression. So now we'll come to polynomial regression. So in polynomial regression, first we have to generate the polynomial features. Rest is just same as the linear regression. So for that I'm importing polynomial features from sklearn dot preprocessing, and now uh, have generated the new polynomial features in xtrain polynomial and xtest polynomial from xtrain and xtest. So I'll take this as my training data set and this as my testing data set. So I'm gonna pass to the model, linear regression model, and I'm gonna evaluate it for testing and training data set, and let's see what we'll get. So xtrain, okay, first we have to run this. So now when we run this, we're getting 0.60 for testing and 0.66 for training. So R2 square has improved from linear regression to as compared to linear regression. So it is we are getting 0.66, like, but we got 0.5 something in linear regression. So even when we plot the scatter plot, the values are very close to this line, as you can see when compared to linear regression. So now let's see what happens when we increase the degree from 2 to 3a. Like, make note that before we restricted the degree to 2, and now we are gonna increase it to 3. So let's see what happens. So you also your auto score is improved much more, and as compared to the what we got in degree was 2, and scatter plot also it is much nearer to this line, uh, accumulated near the line. And let's see what happens for polynomial degree futures. So it has drastically decreased. So up to after some point of time, uh, the performance of the polynomial regression decreases when the degree increases. So I run the scatter plot. You can see the values, the plots are far away from this line, so we are getting much error. So as much between this point and this line, and this point and this line, and this point and this line. So these are some of the places where the error is more. And now let's see what happens for decision tree regression. In decision tree regression, we have to import decision tree regressor from the sklearn tree. So what this decision tree exactly does it? It classifies the regression values into various categories from the range of values in the form of range of values. For example, if the columns has range from 1 to 100, it creates different categories such as 1 to 10 and 11 to 20, 21 to 30, and like so on from 91 to 100. So and it creates as different class, and then it builds a decision tree, and the leaf node predicts the target value. So I'm gonna run this. I'm gonna evaluate it. So from evaluation, so we are getting error, zero error for training dataset, and for testing dataset we are getting error as less as 2.07, 2.82, and we have got auto score for training dataset 1.0, and auto score for testing dataset at 0.83. So we can see till this is the best model till now. And when we plot the scatter plot, you can see it's all the points are nearer to this line. So far, as you guys can see, this decision tree regression best predicts the target, like scales on pressure level. And now let's see what happens with random forest regression. For random forest regression, we import random forest regression model from sklearn.tree package. So I have chosen 100 estimators of trees of maximum depth 4 for random forest regression. So all the predictions of all these 100 trees will be taken into consideration, and uh, we are gonna take the mean or something like that, and gives the final answer, final prediction. So I'm gonna run this package, run this code. I'm gonna test it. So we got better results when compared to linear regression. We got 0.58, and for testing training data set we got R2 score as a 0.58 and R2 score as 0.550163. So it's when compared to linear regression or lasso or ridge or elastic net. So this has given good results, but still we can conclude that decision tree regression best predicts the model. So among all the models tested for the given problem, decision tree regression model best predicts the noise produced by the NACA 002 airfoils. So by this I'll conclude.